I'd like to show you how to use the enumerated data type to make your state codes much more readable and easier to maintain. This basic implementation that I'm showing you right now is using numerical values, and those can be troublesome to work with when you start taking away and adding states as you work your way through the design. What we need to do first with the enumerated data type is establish a custom control. This will be based on the enumerated data type. I'll give that the new name state. The idea for an enumerated data type is that we associate a specific text label with the numerical values. So eventually it's still a numerical value, but we think of it in terms of the text labels. I'll just imagine some generic words here like power on reset state, the start state, the run state, maybe a state where we wanted to do a branch, and perhaps another state where we wanted to do a return. Really, these labels need to be specific to your diagram, whatever seems to capture the intent of what goes on inside that state. Again, each one of these is associated with a numerical value, and that's the way it's physically implemented, especially on the FPGA target. These labels ultimately translate into binary bit patterns, as we would think of for numerical values. And we want to save that away as a strict type def or strict type definition. Again, I'll call that state. So back in the front panel, I can select that control that we've just created. And looking over here on the block diagram, I guess first of all, let me get rid of this one so I don't have the conflicting name here. I want to call this one simply the state of the state machine. Change that out to a constant. Now we have a little bit of data type conflict going on here because I'm mixing and matching between integer data type and enumerated at the moment. So we don't want those coercion dots that are showing up. That's the red dots. We don't want those to persist. But what we see right now is that the case structure suddenly shows all of our labels instead of the numerical values. If we were using numerical values, again, the case structure reverts to that. I'm going to go ahead and take a time out here and very shortly anyways. I'd like to take a time out and just clean up everything, but let me first illustrate that we can then do a control drag. We'll make a copy of that enumerated state, which is our, again, it's a constant. Do a little bit of rewiring here. So we could then say if we're in the state called branch, we can either go to the run state or we can go to the return state depending on the value of signal A. So you see that the block diagram becomes automatically self-documenting this way. I think it's just a lot easier to work with. All right. I did take a little bit of a time out here and have converted all of the cases to the enumerated data type format. Now I lost my indicator at some point in the process here. Let me go ahead and make a new one. So nicely enough, we see that the indicator shows us these text labels for our states. So let me set a relatively long loop time of 1 second here. We see that the state register tells us exactly where it's at in text labels, which is very handy. And sure enough, we see that when reset is active, that takes us back to power on reset state. Now supposing you needed to add or subtract some states. You have to open that type definition and then edit its states. For example, if we decided we wanted to delete the blue state, we could do that, or we could perhaps insert a new one. I'll call this the green state. Go ahead and save the control. The idea here is that when you manipulate the control directly, then any place where you've ever referred to that control automatically is updated. So here we see green appearing in that constant, and then any place where we've got that constant, it will be updated as well.